What is busbar differential protection? Low impedance-based busbar differential protection, also known as 87B, is current-based differential protection, which is very important for clearing faults inside the switchgear and mitigating impact. The response time is very fast. It is one of the fastest protection functions, and it can be used for switchgear with multiple sections. Busbar differential protection works based on Kirchhoff's first law, also known as current law. Simply put, all the currents in the system, for instance in this diagram, which represents our switchgear, what current comes in must go out. If there is a difference, the protection relay sees the difference. This means that there is something occurring inside the switchgear, such as an arc flash, arc fault burning, or copper burning. This must be tripped immediately. In a conventional system, you would need protection relays, varistors, shunt resistors, setting resistors, and other hardware devices for this. Let's look at two examples, two ways to approach this, conventional and with SSC600. Here we have a standard case with 14 panels per switchgear, 7 panels in section A and 7 panels in section B. Both are the same, so for each panel you need standard conventional CTs for the overcurrent functions, which are processed by the protection relay. You also need an additional set of conventional CTs that are sending the analog signals from the panels together to one special 87B relay using conventional wiring. You further need to select the right varistors and stabilization resistors for the 87B relay itself. For a double section, you will need to have it doubled. On the other hand, with sensor-based 87B, you only need the protection relay for the protection functions inside the panel and a set of sensors, current, voltage, or combi sensors. The panels are identical for bus A and bus B, and there is no need to have additional hardware or devices. You only need to distribute the sampled measured values from the protection relay via the Ethernet switch to SSC600. In this case, you can combine the disturbance recorder with 87B and another application in one device. Now, let's have a look at an example. Here we have a Unigear ZS1 medium voltage switchgear panel. This is the side view of the panel, where you can see inside the switchgear and its conventional instrument transformers. In case of 87B, there would be another set of CTs. The first set of CTs are used for current protection of the panel, and the second set for the 87B signal to the 87B relay, so the depth would be about 20% more. For comparison, here you can see a panel with current and voltage sensors only. There is no need to have any conventional CTs. The current sensor is located here, or you can also have two sets of current sensors. The voltage sensor is this small part and it is made of epoxy resin. This means that there is also a large reduction of the weight and footprint of the switchgear panel. Benefits of using SSC600 in busbar protection. The benefits of using SSC600 in medium voltage switchgear for low impedance busbar differential protection 87B include: SSC600 offers a sensor-based 87B protection solution, which is unique on the market. Current sensors have the benefit that they do not saturate, like conventional CTs. You also don't need another set of CTs, so the switchgear panel becomes smaller and lighter. The amount of wiring is reduced compared to a standalone 87B system. The reduction of the material in the low voltage compartment, as well as of medium voltage material, results in a weight reduction of up to 200 kilograms per panel. With fewer devices, there is less engineering and fewer man-hours needed. Further, overall engineering is easier with the common software tool PCM600. Everything is low impedance, so no varistors or resistors are needed. And troubleshooting is easier. All this leads to significant cost reduction.